Did you know that the British government spent 20 years between the First and Second World Wars investigating the possibilities of electrifying plants? And they did it in almost complete secrecy. Yeah. That research wasn't quite the complete dead end that I originally imagined, and maybe not quite as harebrained either. In fact, it was just the first sign of a complete new science, or as many others would have it, pseudoscience, called electroculture. But electroculture has even deeper roots than the period between the war years. I found information from 1780 and 1790 that electroculture was being actively experimented with both in England and across the Channel in France and the rest of Europe. In France, for example, in the late 1770s, Bernard Germain Etienne de la Ville-sur-Illon began some experiments watering plants with water which, as he had put it, had been impregnated with electrical fluid. He published a 700-plus page long essay on electricity in 1781, which reported his findings that the germination of seeds and the sprouting of bulbs was quicker, and when plants were electrified, they grew with more vigour than usual. There were other French would-be electricians too, notably Abbé Pierre Bertrand, who had already written about the benefits of electricity and health and other related subjects. Now, he too tried watering plants with electrified water, delivered from an insulated barrel on a trolley that he trundled along between the rows. In 1783, he published L'électricité des végétaux, which included a description of the first electroculture tool, the electrovegetamometer. You remember the story of Benjamin Franklin flying a kite to attract lightning? Well, that's what Berthelon aimed to replicate. He set up miniature lightning conductors to collect electricity from the atmosphere and then distributed the charge via wires across the garden. Don't ask me how precisely, it was too complicated to read and translate the 18th century technical French. But this picture should give you the general idea. Now, things really started to buzz again in the 1840s when a whole new generation of experimenters began to test out new theories and report their findings in serious scientific journals. This was probably due to the invention of what was called an earth battery by Alexander Bain in 1841. Bain's device operated on the same principles as a modern battery, except the zinc and the copper plates were put into the soil and connected above the ground by wires. Plants grown in the area between the two plates grew faster and yielded more. So in 1844, Robert Forster, a Scottish landowner, used what he termed atmospheric electricity to substantially boost his barley crop. The details were reported in the British Cultivator in March 1845, local newspapers across the country, and Letters on Agricultural Improvement also reported on it. They added that Forster was still indeflatably employed in collecting electrocultural facts from our most eminent electricians. So I don't know where Forster got the idea from and discovered that he was far from unique, that there were plenty of amateur scientists who had never stopped trying to perfect a way of getting electricity to boost plant growth. Forster had, for example, read in George Glennie's Gardener's Gazette about an experiment by a lady who caused a constant flow of electricity to be afforded by a common electrical machine to proceed from a summer or garden house, and which was diffused by a wire to a fixed portion of the surrounding ground, and the effect was that vegetation did not cease. So, obviously she tried a similar thing and had positive results. Now, much of the early history of electroculture in both Britain and on the European continent, including Forster's work in Scotland, was written up by Edward Solly, a Fellow of the Royal Society and an experimental chemist to the Horticultural Society. They published on the influence of electricity on vegetation in the Journal of the Horticultural Society in 1845. A lot of people were still very sceptical, though. The Farmer's Guide to Scientific and Practical Agriculture said in 1851 that although electricity could be classed as a special manure, no one has yet been able to reap similar advantages from similar experiments as Dr. Forster obtained from his. And it's doubtful that electroculture will be pursued further for some time. So after this flurry, once again I thought that was the end of electroculture, but I was wrong. In the 1880s, Professor Carl Lemstrom of Helsinki University, a geophysicist studying the aurora borealis, or northern lights, began to wonder if they had an effect on plant growth, because he noticed that the trees in the far north grew rapidly despite the short growing season. This led him to experimenting with the effects of atmospheric electricity on the germination of seeds and plant growth. Lemstrom's results attracted international attention, and he was able to conduct some of his later experiments in collaboration with other scientists in Sweden, Germany, and England. Eventually, in 1904, he published Electricity in Agriculture and Horticulture, in which he offered his detailed findings that there was an increase of the harvest of every kind of plant which has come under this treatment, but also a favourable change in their chemical compounds which made fruits sweeter and their scent stronger. Around the same time, in France, the Agricultural Institute at Beauvais, under its director Father Paulin, began what they hoped were a series of experiments to decide once and for all whether this electrical charging worked. Paulin refined Abbé Berthon's electrovegetomometer, devising an atmospheric antenna that he called a geomagnetifier. Installed initially in a field of potatoes, plants within its reach were greener, healthier, and produced more potatoes. Later, it was tried in vineyards and produced sweeter, larger grapes that produced better quality wine. Another researcher, Fernand Bastille, installed one in a school garden, which he named after Abbé Berthon. Bastille then went on to organise the first International Conference on Electroculture, held in Reims in northern France in 1912, which showed that there was an active research going on across the globe. Britain had particular reasons to be interested because of food shortages during the First World War caused by a blockade by the German Navy. It became a government priority to improve agricultural and horticultural production. So in 1918, a group of British scientists set up experiments to test the efficiency of electricity at boosting yields. These generally appeared to show impressive, though not universal, increases. Nevertheless, it resulted in considerable interest from the agricultural and horticultural communities who lobbied the government for further research. In response, the Board of Agriculture set up the Electroculture Committee to investigate further. Membership was impressive, an interdisciplinary mix of physicists, biologists, electrical engineers and agriculturists, including a Nobel Prize winner and 6 Fellows of the Royal Society. It was chaired by Sir John Snell, chairman of the Electricity Commission. Unfortunately, their field trials, based on the idea proposed by Lemstrom, on a wide range of crops, suffered from several years of bad weather, and they were forced to use plants in pots. Nevertheless, their results showed that the electrocultural effect was real and it promised substantial gains. But unfortunately, that they were also highly erratic and hard to control. Meanwhile, work in other countries, including the US, was a little less encouraging. The Department of Agriculture issued a bulletin in 1926 which concluded that a review of the literature of electrocultural experimentation up to the present times does not lend assurance of great progress. 10 years later, in 1936, the British Electrocultural Committee was wound up, concluding that there was little advantage to continue the work either on an economic or on a scientific ground, and regret that after so exhaustive a study on this matter that practical results should be so disappointing. So electroculture was clearly now seen officially as a curious but unreliable phenomenon, and pursuing it a waste of time. Once again, the interest faded away. However, David Kinahan of the Department of Science and Technology Studies at the University College of London, who had researched the committee's work, came up with another interesting fact or two. He discovered in the National Archives that although their annual reports contain many positive facts, these were never made public because from 1922 onwards, their reports were all marked not for publication, with only 2 copies ever printed, one for the minister and one for the archives. Although the work was not a classified secret, he was able to ascertain why effectively the committee's findings should have been suppressed like this. Has anyone got any thoughts on that? Things were definitely not secret in France, where Justin Christophe Fleur, an engineer and inventor, wanted to do away with chemical fertilizers but still improve plant growth, rejuvenate old plants and deal with many pests and diseases. He experimented in his own electric vegetable garden using what he called an electromagnetic pterocelestial power. It was well reported in gardening and even in national press that he travelled the world lecturing, eventually writing it all up in Electroculture, which was translated into English. I've read that book myself. Short, sharp read. Gives you everything you need to know in about 70 pages. Despite being persecuted for his inventions by lobbyists from the Agrochemical Centre, over 150,000 of his devices were sold before war broke out in 1939 and closed the factory. Christophe Fleur still commands a lot of interest, and although he died in 1938, he has his own Facebook page and an official archive. As a result of all the work of these early researchers, there was plenty of evidence, even though it was of variable quality, and they kept asking the question, how can we make this work better? But there was no convincing answer as to why electricity had these effects. There were all sorts of theories, but no certainty until the Indian plant physiologist Sir Jagdish Chandra devised incredibly sensitive equipment to prove that plants responded physically in the same way as animals do to electrical impulses. This was written up in a series of books by him, including Response in the Living and Non-Living, 1902, Comparative Electrophysiology, 1907, and The Motor Mechanism of Plants, 1928. Now, despite further research, it was not until 2006 that Andrew Goldsworthy, a plant biotechnologist from Imperial College in London, put forward what seems like the most likely explanation for what actually caused this reaction. He showed that what is seen in electrocultural experiments is a plant's natural reaction to a brewing thunderstorm. Physicists, meteorologists and other scientists agree. So if, as this suggests, the electrocultural effect everyone is investigating is a simple physiological response, then why, I wonder, aren't our fields full of devices designed to fool plants into thinking that there was about to be a thunderstorm? Plants need water, so plants in dry locations gain an evolutionary advantage if they can maximise their use of sudden downpours, such as produced in a thunderstorm, before it soaks away. Thunderstorms carry an electrical charge, and somehow plants have learned to read that as a signal that heavy rain is on its way. what lab experiments show was that the optimal electrical charge to be applied to plants to increase yield turned out to be similar to the charge that is present in a thunderstorm. When it receives the charge, a plant activates genes that speed up its metabolism, and that includes increasing the rate at which the roots can absorb water, and thus that encourages growth. So if, as this suggests, the electrocultural effect everyone is investigating is a simple physiological response, then why, I wonder, aren't our fields full of devices to plants into thinking that there was about to be a thunderstorm? So thank you for allowing me to share what I've recently learnt about the fascinating subject of electroculture. In next week's video, I'm going to be showing you exactly how you can attract the magic electrical flux into your garden and improve the growth of your own plants. So stay tuned to Tiny House and Off-Grid Resources. The next video, I will be dropping a link up here. Won't be there immediately, it will be there after I've created the video. So anybody watching this subsequently can jump from this one, the history of electroculture, straight into how and why it works.